Hi Madhusudan, hi everyone, Lokesh here. Hi everyone, Lokesh here.
Hello sir.
Hi everyone, Lokesh.
Hello sir.
Hi everyone, Lokesh.
Hello. Sir, you're audible sir.
Yeah. I'm hearing a lot of echo in the background.
Hello? Hello? Good morning, Gurunda. Request audience to mute your audio, please. Yeah. Okay. So good morning, one and all. So welcome to the second day of our 1 week online STTP on automation technologies in FMCG sector. So myself, Dr. Madhusudan, Assistant Professor in the Department of Mechanical Engineering. And before going to the today's session, let me welcome today's speaker.
Hi, Madhusudan. I hope you are able to hear me. Yep.
Yes, sir. Your voice is audible, sir. Engineer from the year of 2005 to 2009. Later, he has joined to the Sandhar Technology Limited as a graduate trainee from the year of 2005 to 2006. So again, he has worked as a project engineer during the tenure of 2006 to 2009, and in global OEM technical consultant from the year of 2009 to 2011, and senior global OEM technical consultant from the year of 2001 to 2015. That's a 4 year, and global OEM technical consultant lead from the year of 2015 to 2018. And currently, he's working as a regional segment leader of a packaging machinery Asia Pacific. That's a Rockwell Automation. So he has, and we have. It's a pleasure to have you with us today, sir. So, and on behalf of our department and my personal, it's a warm welcome to you, sir.
Perfect. Thanks, Madhusudan. Thanks for the introduction. So, as you can see, that I've been working on machines for most of my experience, and it's wow, it's almost 15 years today, right? That I've been working out in the field. So, my request to all the participants will be that you can go forward and keep on asking us questions while I'm walking through the presentation. And let's make it interactive as much as possible. Yesterday, you got a brief overview into various applications that could be done in FMCG space, and also the different levels of automation, starting from level 0, where you see equipments and their direct control systems, going up to the information layer and the plant layer where the entire planning happens. And how these systems interact with each other is where the whole game happens in terms of increasing your productivity, reaping the benefits of automation, and all of that, right? So today I'll focus on robotics and independent cart technology. I see that these are the two technologies which are not that widely being utilized in FMCG if we look at a few years earlier, but they are picking up the pace, right? As soon as you say robots today, right, what comes to the mind is these big welding robots that are used in automotive space, right? But then there are plenty of applications and requirements where robotics technology is playing hand in FMCG space. And then specifically when it comes to packaging, it is like a combination of robots along with machines that help you achieve flexible manufacturing, right? With that being said, I'll just get started, and feel free to put your questions in the chat window during the presentation. I hope my screen is visible. Madhusudan?
Not visible.
Not visible yet. Okay.
Yes, sir. Your screen is visible. You can please go ahead.
Perfect. Thank you. So I'll just talk about where the flexible solutions come into play, right? When we talk about manufacturing today, we see variety of products out in the shelf, right? Different products, different shape and sizes, and that is leading. I'm getting some background noise. Okay. So, okay. All right. So in the manufacturing space, we are seeing that there's an explosion of stock keeping units, and depending upon the changing scenarios, right, there's a different requirement coming out from the market, and that leads to an increasing number of stock keeping units, and in turn, different type of manufacturing requirements that generate out of it. For example, if you're manufacturing a product, let's say of a size uh, 50 grams, and you want to change it to 20-25 grams, there's a lot of modifications that may required on a line in traditional manufacturing setup, where we were manufacturing a single type of product but in large quantities. In today's time, it is required that we manufacture multiple different shape sizes depending upon the market requirements, and use that in different forms and factors to sell out in the market. Right? The other factor that really contributed to this was the current ongoing pandemic, right? It kind of made us aware that how we quickly need to adapt our manufacturing requirements. Manpower, which is available to a large, which is available and cost effective in our country to deploy, has kind of moved out of the equation with standard operating procedures that have come into place to avoid spreading, right? You need to have safe distances between people operating on a shop floor, right? You need to make sure that your equipment still continue producing up to the mark, and that is wherein some of the lines were also repurposed and retooled to quickly adapt to the needs of the future, right? So as a necessity from a machine builder side and a customer who is manufacturing products and selling it out into the field, there's a need to have a long-term perspective and look at that how the equipment, the capital that they are putting in place and buying these large assets could be reused in future to meet their long-term requirements, or even what is the level of flexibility they provide to adapt in terms of handling different shape, size products out during the manufacturing requirement. So the machine builders are working in terms of understanding these requirements of their customers and then accordingly supporting them to have a flexible solution that leads them to reduce the downtime, right? So the best way of solving today's problem is that you look at utilizing innovative path breaking technologies that help you to adapt and solve the challenges on the fly. And while doing that, make sure that you are able to reduce the changeover times from product A to product B, as well as making sure that there are no challenges and hence the lines are able to over the time. In this evolution of the journey, manufacturers, machine builders, they are working together to act as partners. It's no longer a transactional sale wherein you just provide and that's the end of the story. You need to understand needs and accordingly deploy solutions which are ready to be used for the longer term. And at Procter, we have that experience of working with the for many years and many decades put together. What I'm bringing to in terms of how some of the newer technologies can be deployed. So the first I'm going to talk about are robotics. There are a variety of robots which are used out in the floor, and the way of using them is that they typically come with a dedicated robot controller, and hence you need to have skilled manpower on your shop floor which understands how these robots are to be programmed, how they are to be deployed in the field, right? As well as the machines are typically controlled in a skid solution using a PLC or solution, and this typically there's a lot of network exchange and hardware interlocking that happens between a traditional robot control and a machine controller. Now, this is wherein you see that there are inventory management challenges since you need multiple type of hardwares. There's a multiple programming software requirements. There's an increased complexity since while you have an issue and you need to solve it, there are multiple levels where you need to address and identify the catch. And in turn, there is a heavy dependency on the robot supplier that is there to keep these systems up and running. A new way of doing this is that you utilize the same PLC that you are using for controlling the rest of the equipment around that robot, be it conveyors, movement axes, or other devices, and you put all of that together and utilize the same PLC also to control the robot. What you're seeing here is a delta robot mechanism, which is a type of a parallel robot and is capable of achieving pretty high speeds, going up to even 200 picks per minute in today's time, and tightly integrating the same with the vision system so as you're able to identify where your products are coming in, so the requirement for pre-sorting comes down, and in turn this becomes a single solution wherein you have a single point to diagnose and to keep it running, as well as for the maintenance and the operation staff. They still need to just know one environment, that is the machine HMI, that they can utilize and deploy. While we are doing this, there are a variety of geometries that are actively being utilized, starting from simple Cartesian robots, which are used in applications like plastic molding, press applications, sealing applications, a variety of pick and place. The moment you say pick and place systems, you will start thinking about a Cartesian robot putting a XYZ gantry and then utilizing that for the smallest of the tasks, right? And by leveraging coordination, you can really improve the productivity on these things moving forward. As a delta robot, these are, since I indicated that these are high-speed geometries, you are capable of going up to very high speeds, and thus these are being used in line to the manufacturing solutions, and thus a pick and place can be performed, identifying the product inflow and putting them into required packing solutions. These are also being utilized for high-speed assembly solutions, primary packaging, handling of various material types. The SCARA robots in parallel are being utilized when there are multiple operations to be performed, and they are widely being used in primary packaging today, wherein you are discarding products depending upon the good products and the bad products, and it is also being actively deployed in FMCG space. When it comes to high-end articulated robots, they are being utilized for palletizing, secondary packaging, specifically in FMCG space. Now, depending upon different geometries, the complexities, the equations that you need to implement, they change. And what advanced controllers in today's time are capable of doing is that all these control geometries are already pre-configured and deployed inside the controllers itself. So you just use a graphical interface to program the key parameters, which is like joint lengths, positions, and orientations. And thus you are able to deploy these solutions out in the field really fast and trouble-free moving on, right? And thus making sure that you are able to adapt to the changing requirements. Okay. Let's look at a video of one of the solutions, what you see over here is that there are multiple Delta robots which are utilized to pick the packages from a conveyor, which is coming from a primary packaging area, and then packing them into cartons so as they can be utilized for shipping it out of the factory. Right? What you see is that these multiple robots, they manage the load handling in terms of inflow of the products and the outflow without actually stopping on a regular level, and thus achieving the highest level of throughput available. The flexible pouches that you see on the bottom, they pose an inherent problem. When you are doing a packaging with people, you can very comfortably do that by picking it up. But when you have to arrange these systems on the fly in machines, because of the odd shape and the, I'll say, unbalanced weight distribution in the pouches, that becomes really complex and leads to a lot of wastage in the pouches. The solution over here can be readily deployed while minimizing the amount of activity required on pouches from collating perspective, and that is done by the robots themselves. Okay. Any questions still here? Otherwise, I'll continue moving forward. Right. Let's look at a variety of applications that can be handled with integrated robot solutions. You can deploy them for cartoners, case packing, product sorting, mix packs, wherein you are putting different type of products into a single carton for usage. A good example will be all the festive packs that we see. For example, a single chocolate box has got multiple variety of boxes or chocolates in it, and those all could be put into a robot's access area, and those could be, in fact, done. The boxing can be done automatically. Palletizers, variety of product handling solutions, and also I see cosmetics, right? Or what we call as beauty care is one of the area where you'll see most innovative shapes and sizes of the products, and that is where robots making those pallets really comes in handy. Right? Various type of meat processing lines, cookie and chips lines are being utilized and executed utilizing robots today. Any questions? So let's look at the benefits of this integrated robot control before I move on to independent cart technology. Right. So to sum up, it's a single environment that allows you to take the complete ownership and control of the solution. The product changeovers really become easy because you can now utilize the same machine HMI to press a button, and accordingly it will be configured as per the recipe for the next product itself. So giving you a high level of toolless changeover when you're moving from product A to product B. There's a level of flexibility that you're able to achieve, since with robots you just need to define the product shapes and sizes. You can easily deploy them in your machines and minimize your line's footprint. They support a modular approach, right? So you can build a block of machine and you can think about how you can utilize the program to deploy multiple such solutions. Right? There's a high level of performance and support that you're able to achieve. It's a single system, so you just are dependent upon single supplier from inventory perspective as well as from support perspective. There's a single network to manage that highly simplifies the diagnostics and the support that you need. Right? As well as, the single network also enables a high level of efficiency and granularity in terms of the information that is available for you to access. Right? Thus, doing a detailed analytics is highly possible, and defining that what is the level of solutions that you could utilize and what are the significant improvement areas. Okay. Independent cart technology. While I moved there, so robots have been able to provide you flexibility in a particular location, right? but still the material movement has been largely dependent upon existing conveyor technologies, and the level of flexibility you can get with respect to conveying different shapes and sizes is highly limited. And the other thing I want you all to imagine is that if you have a line that is doing multiple processes, all these conveyors will need to start and stop till the time your subsequent processes are being carried out, right? And thus your throughput of the line depends upon the slowest station in a particular line. So you need to think about how do you increase the speed of such stations, or you will put parallel stations in your manufacturing today. Now, with independent cart technology, you are able to gain flexibility and throughput without sacrificing anything, right? So let's have a look at what independent cart really is by the means of this video, and I'll explain it in parallel that how we go about this, right? So when you look at the machine evolution, the traditional systems were single type of product, but multiple quantities. And thus we were using camshafts and designs which were limited in terms of the flexibility they could provide. As we move forward, in order to gain flexibility and reducing the load requirements, we started utilizing servo motors, which helped us achieve changeovers at a much faster pace into the machine. And thus, we were able to kind of increase the productivity on the shop floor, right? And what we have today in terms of independent cart is that instead of the pocketed conveyor that you see over here, you have freely moving movers on a particular track. And what you see is that you are able to produce a combination of different stock units at one go in the line without any changeover times, right? So what you see is the 3 products being packed into a single carton or into individual cartons in the same system as you're going forward. So what it really is that instead of carts being linked together to each other and you convey from one station to another, you are able to have carts which are carts or movers which are independently moving along a track. And that really is providing you individual product process control throughout your processes, programmable position and speed in different parts of a machine. So as you are able to have a control for smooth movement of your products in the system, and extremely flexible and reliable, since you reduce a lot of transmissions which are there in the traditional systems. All right. So let's look at the second video here. This will help in defining the overall process further. What you see here is a demo smartphone assembly line, right? So depending upon how much speed is or time is required for a particular operation, you see that you're either using a single station or you're using multiple stations to perform the operation at the same time. And you are also able to combine the continuous flow of the products as well as starting and stoppages depending upon the requirements. For example, testing is a long time-taking activity. That is where you see that there are multiple parallel stations which are performing a detailed testing on the solution. Right? So let's look at what the technology really is. You need to consider a motor, right? And open it out and lay it on the floor. So what it really is that you have got the entire electrical coils laid out on the track, and then the magnet in turn reacts with the field that is created by the track itself, right? And each of the complete intelligence lies in the bottom track itself. So the mover are basically passive components, and there is no need for any cables that are moving along with the movers. So carts move passively, and the loop is completed by the motors itself. Integrated sensors within the motor provide you inherent track and trace capabilities. So you know that where a particular mover is with respect to a moving system, and thus you could reduce a lot of external sensors and identifications that you need to put on such carts. Right? Since the motor coils are stationary, there's no flex cable requirements. It highly reduces wear and tear in the system. And this technology can be applied in terms of straight sections, curved sections, and they could also be mixed to create merge and diverge functionalities. Right? What you see on the right-hand side is a real system demonstration moving in the real time. Right? From a system control perspective, there are a variety of technologies. Now, since you now have these infinitely independent movers out on the machine, which are to be managed, you can even have systems as large as 100, 200 such movers. How do you go about programming it? Right? So there's a nice way which is synonymous to hiring a taxi. You simply put your start point and destination in the car in an application, or you tell it to the cabbie, and then you can sit back, relax, and enjoy the ride. Right? In the same manner, you can use these systems in what we call as fire and forget systems. So the whole system will automatically manage, look out for the traffic, do a starting, stopping based on whether there is enough space available in the system, and go from a start point to a destination in the minimum time. This highly reduces the development times while providing you with the flexibility of defining your start and end points at any time. The second way of controlling is a synchronous control, wherein you may need to synchronize your mover to an external device, right? And that is wherein your system can synchronize with a robot moving in parallel to a component being filled, or let's say to an external encoder. So this really helps you achieve a tighter performance, and it goes forward as an optional component on Magnum products. There's an intelligence that is built within the system, so which we call as a brick wall and headway. This ensures that while the movers are moving independently, they're not colliding into each other, and thus creates least amount of nuisance in the running system. So while a vehicle is in motion, it requires a forward distance depending upon its stopping time. So it looks at the maximum velocity it is going and the deceleration, and accordingly it maintains a safe distance from the mover up in front. And that way, it always ensures that there are no collisions happening in the system. I hope this gives a good peek into the technology as such. Next, let's look at variety of products. So the products are majorly classified depending upon the load capabilities they can perform up to and they can handle safely. So there are three broad line of products: Magnum Over Light, Quick Stick HD, iTrack. They inherently utilize the same technology. The entire system differences are with respect to the payloads they can handle, the way they are deployed. And Magnum Over Light comes in form of modular components that you can purchase and put together to make a flexible conveying solution, utilizing movement from machines to machines or within the machines itself in a modular format. Right? Quick Stick can go up to load handling of thousands of kgs. Thus, it means that larger motors, larger drive solution units, and larger movers as well. Right? iTrack is the highest accuracy system that we have today, and it provides automatic synchronization with motion axis and a very highly dynamic product in itself. Any questions? Go ahead. Okay, so I'll just move on. So what you see on the right-hand side is a magnet mover light system demonstration, and these are utilizing air core motor design. So there's no attractive force between magnet and the coils on the bottom. It has got integrated drive, and that way it is really neat to deploy. There's a minimalistic wiring that is required in the system. It has got integrating guidance, track and trace mechanism, and you could have a freestanding or deployed with a full system with all the motor supports, everything from Rockwell Automation. What you see is that there are primary components like cart, straight sections, curve sections, and switches, which you can put together to create any type of format as required by you. Okay.
Loki, sir, is it working based on the magnetic
Uh,
pathway?
Yeah, it is a magnetic pathway itself. So all the carts itself have magnets on their bottom. Okay. And the track as such is not a magnet, but it is an electrical coil which creates a field to propel the magnets forward or backward. And inherently, it's a bidirectional solution.
Then what would be the accuracy? How it get self-control? Okay, in case if I want to move from in the straight, in the curvilinear, okay, how it is going to be controlled?
Okay. So from an accuracy perspective, these systems go up to, I think, half a mil, magnet mover light specifically, whereas iTrack can go up to 10 to 20 microns of accuracy, right? So coming to the answering your question on how you effectively do the position control on these things and maintain a positioning accuracy. So there are sensors built into the motors itself, right? So what you see as a straight section, it has got inbuilt position control that it synchronizes with and reads the cart's position. So you don't need any external stopping mechanism or positioning mechanisms for the accuracy as such over here.
Okay, what would be the application, sir? This is where we can use this kind of.
I'll come to that as well in a while. So
Okay,
we'll just talk about applications later.
Okay.
So as a any other questions in the meanwhile?
Sorry, sir. Thank you. You can go ahead, please.
Perfect. So these are variety of options which you can utilize to put together solutions, right? So there are standard rails which are available, or a rail-less system wherein customers may want to build their own guidance mechanism. And I'll say that the engineering students can innovate a lot around with rail-less systems. All right. And then there are a variety of carts. There are glide carts which practically are supported by the rails, and they are propelled as it is. And the load capacities are, with a single cart, you can go up to 1 kgs. And with a tandem cart, you can go up to 2 kg. And having accelerations up to 2 meters per second square. Right. One interesting part to consider here is that you are only utilizing power in the area where you're moving, right? Comparing that to a standard traditional conveying mechanism, you are having a connected chain which has got multiple pockets on it, and in turn, you are moving that complete chain always, right? So that way, there's also a lot of energy savings that you get as a part of these solutions. With a wheeled cart, you can go up to 8 kg plus solution with the tandem one, and 4 kgs with the standard single puck. Okay. So again, a similar concept, but since over here we are looking for a higher thrust, so the motors are iron core design, and that in turn provides a greater level of pull between magnet arrays and the motors itself, that we call as quick stick linear modules, right? Whereas magnet mover comes in forms of modular components, quick stick is sold as magnet arrays and the motors itself, whereas the rest of the system is to be designed by the customers themselves, right? So that is wherein highly skilled mechanical manufacturers for machine and equipments are providing consultation out in the field to utilize it. Right. In terms of iTrack, I already mentioned that it is a variety of scalability, and it is the highest dynamics, highest accuracy system. It can go up to accuracies of 30 microns, 10 microns, depending upon which product you're deploying. And our team, in fact, works very closely with the person who wants to deploy it, and understanding their requirements, we can even provide certain solutions which are customized depending upon the customer requirements. Okay. Various type of customizations are available in terms of liquid cooled motors, heavy payload motors, large radius, and in fact, we can do the entire customization depending upon what you really want to achieve here. Right. So just a quick look at different features in terms of how close you can put the two movers together. Just like a thread pitch, we talk about mover pitch over here. In terms of iTrack, you can get close to 66 or 75 mm. Whereas in case of the iTrack 5730, which is a product specifically designed for packaging machines and the smaller equipment handling, you can go as close as 50 mm or 5 centimeters. Right? You can utilize these products in different orientation. That means horizontal, vertical, or standing up. That means you can go over and under a particular machine and solution. You can go up to velocities of 5 meters per second while achieving accuracies and repeatability of 0.03 mm or 30 microns. With the iTrack 5730, it is 10 microns. I'll need to have that corrected here. Okay. So let's have a look at the applications. I know this call was centered around FMCG, but there are a variety of applications where you can deploy this technology. So I'll first talk about FMCG and then I'll break into other applications. Right? In FMCG, you can utilize it for mixed packaging, high and low speed cartoning machines, pouching, flow wrapping solutions. Right? And what you see is the colored legend indicates that which particular type of product is the best fit for those applications. Right? I also see these being highly adopted in a variety of cutting and slicing operations for specifically in meat processing areas. And I'll walk you through a customer story on that as well. Right? In glass manufacturing, there's a lot of tempering that is done on the glass, moving it through different stages while cutting it on. So all of that is kind of material handling of the glass from station A to station B. And that is another area wherein it is highly being utilized. Right? So different SKUs, pouching solutions, cartoning solutions, variety of filling and assembly solutions is also where you can utilize it. Right? So imagine if you have to make a 30 micron accuracy mechanical transmission system, what is the level of conveying precision that you will need from station to station. Right? You will have to use certain external devices to make sure that your components are sticking and they are staying in the right position. Whereas over here, you can do that, getting rid of all those stoppers in the system. Right? In case of life sciences, it is being used in medicine handling, cartoning, case packing. It is even being utilized for sample testing, right? All these lab samples that we give, and it is to be tested in a controlled environment. Manufacturing of eyeglass lenses, contact lenses, a variety of medical devices wherein you are bringing multiple components together and sending it out. Will be pre-filled syringes. We get this medicine already filled into a syringe, so as it is easy to home administer. Right? Going out of FMCG space, we are seeing space, warehousing, and entertainment units. Longest amusement rides is designed using Quick Stick HT, and it provides you a solution, and it is somewhere in kilometers in length. I'm missing. Okay. Automotive electronic battery assemblies, specifically wherein takt time is something really important for the process to happen seamlessly and at a higher productivity rates. We are also seeing it being utilized in body shops, paint shops. So I have brought in a few customer references and key successes. So as you're able to wrap your heads around the concept and how it could really become a part of it. I would have loved to throw a quiz that's figure out where the independent card technology is sitting in these machines, but it'll be pretty evident. So let's move forward. Any questions at this point? Otherwise, we'll have plenty of time to discuss the same.
So yes, sir, I had one question. Any difference between magni movers and quick stick, sir? Quick stick.
Yeah, there are few significant differences, right? So magni mover, as it is, so these first thing I want you to understand is that these are product names, right? And product names are done based upon certain characteristic differences between each other. So magni mover light can handle loads up to 10 kg, right? While providing you accelerations and deaccelerations in the range of 2 meters per second square of accelerations. And as you are increasing the load, those acceleration becomes lower, right? With quick stick, you can handle load up to 100 kg. Okay. And with quick stick HT, you can handle loads in multiples of thousands of kgs. So that is wherein the key difference lies. And in order to generate that required amount of thrust, a magni mover light is actually a light duty product and it has air core motors. Whereas in case of quick stick and quick stick HT, they are iron core motors as such. Right?
Okay, thank you, sir.
Perfect. On the application side, I'll really say that warehousing and the level of demand that we are seeing in e-commerce space is wherein it is a really great product to utilize, specifically around fulfillment automation, because when you place an order, you really can't predict it inherently, that what is the shape, size of the product that you're going to ultimately be handling in such systems, right? And also the randomness of pick positions from the stock or from your automated storage systems out to different combination of delivery locations. That increase randomness is very tough to predict and plan a system around. And that is wherein leveraging independent card technology and simulation tools along with it really help you make a system which is highly flexible while catering to the inherent stochastic nature of warehousing applications. Let's look at a few customer use cases. The first one is on the throughput side, right? What you see on the bottom is a video of the machine playing. Well, a quick question, where do you see the ICT on this machine, right? So I'll leave you all to answer that in the chat window, but let's move forward. So this is a machine which is being utilized for packaging of diapers. You can imagine diapers, sanitary napkins, variety of products, even masks for that matter, right? The inherently, I'll say that over past 5 to 10 years time frame, the diaper manufacturing machine speeds have been growing up significantly, and it has been by leaps and bounds. Whereas the packaging machines have always been limited by the inherent mechanical designs as to how best you can achieve that speed, right? And this particular customer, which is Optima, they kind of peaked out at what best could be done with a traditional mechanical solution on a diaper packaging machine, right? And in turn, when they started evaluating iTrack for packaging, their main requirement was that they need to change the technology on the machine so as they are able to achieve a higher throughput. Over here, you see that there were two movers. Let me play it again. So as what you really see is that there are two movers moving together. They have a rail on the bottom, which is the arrangement to handle the diapers, and they are moving from station A to station B in synchronization. So I'll pause where you'll see that synchronization area. Sorry, my bad. Pull back. Come here. So what you see here is that as the incoming diapers are coming in, the second mover is moving slowly out, right? Thus increasing the space between the two movers, and that is where the diapers are being held. And rest of the system application really becomes simpler from there onwards, right? The next is a particular test lab wherein every sample is unique, okay, and they need to perform different type of test combinations on same. So let me reduce the voice and I could explain. It's a simple music over there. So each testing sequence of a sample is going to be unique, and comparing that to a standard labor-based testing sequence wherein you do a lot of tracking with respect to what are the tests required, moving that to different stations. This system inherently, while it puts a sample into a mover, it defines that what are the various tests are to be performed, and then the movers take that parallelly to different stations, right? The corresponding tests are performed. There's a level of tracking that is done automatically in the system, and thus you are able to provide optimized process time, a higher throughput, and a better utilization of your test equipments, ensuring that you are able to perform the best results as you go forward. So the solution was MagnaMover automatically routes the samples along the stations, independent control, providing quality control in terms of tracking and tracing, as well as this system could be easily expanded and put together to cater to a much larger requirements, and is a very easily replicatable one. Now let's have a look at the video. So what you see is that these movers are moving along a common track, right? And then there are offshoots, or what we call as spurs, with which these samples move out and go into a processing station. And then they come back and join automatically into the main queue for further processing, right? The flexibility to program each of the movers independently, defining velocity and accelerations, really help you to handle fragile solutions, fragile vials safely without any breakages. The system remains up for a larger amount of time since there is really no components rubbing together each other. So there's a very low breakage and low energy consumption in these systems. Right. This is another example I put together. So this is a meat processing line, right? And what you'll see is that after the slicing, how different type of meat combinations are packed into an easy to consume package for the customer. I see someone is unmuted himself. So any questions there? And all these robotics, the movers, everything is being controlled by the same programming environment, the same solution as such, thus providing you a complete control of the application over here, right? and you could simply change from a one combination to different combinations by just changing the recipe in these solutions. So you have a complete centralized control of it at one particular position. Last but not the least is another example that I put on out of the FMCG space, which is from automotive, right? So this is a standardized solution now provided by KUKA, one of the leading robotic suppliers out in the field, specifically in automotive space, right? And they replaced their roller bed conveyor with a quick stick based solid state solution, which has got moving carts which are carrying a particular body across different stations for the working purpose. A quick look at the comparison of inventory, right? You see that there are just 2 to 3 standard parts which are utilized in the independent cart-based solution versus hundreds and thousands of parts in a traditional roller bed conveyor system, right? This solution has performed without any breakdowns for multiple years consecutively, right? While ensuring that the system stays up for a longer time. There's a reduced number of change parts which are required, as well as they are able to handle multiple jobs on the same frame or jig together, right? This is the level of flexibility that you are able to achieve with independent cart technology. Now, before I conclude my session and we open it up for the questions further, I'll simply like to highlight various values that independent cart technology brings. It helps you achieve higher production rates, right? There are 2 ways. One is that you are able to gain higher throughput. The second is that between the changeovers from product A to product B, there's a minimized downtime. You can simply change those things by push out of a button and your line will synchronize accordingly. You're able to optimize the machine design. Now, majority of the machines out in the field need a combination of intermittent motion, that means start and stop motion, to gather the products and then process and pack them either continuously or in a different fashion. And that combination can be easily done with a single component of independent cart. In terms of flexibility, it really helps you achieving what is your goal today, as well as it could be easily repurposed for your requirements in the future. With that, I'll close the session for today and be open for any questions. Thank you. So let me quickly check for any questions. Hi everyone, in case you have any questions, please move forward and ask them right now.
Sir, instead of servo motor, can we use synchronous motors?
By that, Mr. Patel, you mean that these independent cart motions solutions?
Yes, sir. Yes, sir.
Definitely, yes. A quick comparison of when you will use a servo motor, right? And specifically when you're using a servo motor for a linear movement, you're either going for a linear servo motor over there, or you will use a rotary servo motor and you'll put some sort of transmission mechanism in front of it to make it linear, right?
Yes.
That is exactly the space where you could utilize these linear synchronous motors or independent cart solutions as it is.
Okay. Sir, can you tell about your Rockwell industry, like what are the products you people?
So that way, thanks for putting that question up, right? But a quick answer will be: we are an automation company with information solutions as our key focus, right? So we provide you the solutions entire from the plant level and the enterprise level, wherein you could connect to MES solutions and manufacturing solutions, and then down to the control layer, right? So that means automation controllers like PLCs, PACs is our product, servo motors, servo drives, AC drives, sensors, safety solutions, you name it, we have it, right? So that's the whole portfolio of Rockwell Automation in a quick glance. But I kind of kept today's session entirely surrounded around some of the core technologies, which we believe will be changing the way we look at FMCG sector today.
Okay, fine, sir. Thank you. And one more question. It is a student point of view. Okay, in case if students approach in terms of for internship, kind of any OJT, okay, is there any chance of is there any kind of opportunities in Rockwell in case, for example, master degree student, in case if you want to pursue research point of view, so is there any kind of opportunities you can
so I'll not be the right person to comment, but I know that we do provide some level of training opportunities to people. So you'll need to write down to our HR for those requirements.
Okay? Fine. Thank you so much.
Yeah. Any other questions? Anybody? Otherwise, Madhusudan, over to you. You can send me any questions that may come from students. You have my email ID, and I could respond back to those. Thank you very much.
Yeah, sure, sir. Thank you.
Thank you.
And thanks for your wonderful speech on robot cards and card technology and all. Thank you very much for your wonderful time, sir.
Yeah, thank you. Thanks everyone for your patient listening, and in case you have any questions, you can write it back to me. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Lokesh, sir.